Hello and welcome. In this video, we're going to solve this problem: y prime prime minus 5y prime plus 6y equals to x squared. Right, this is a second order differential equation. Right, a second order differential equation is in the form ay prime prime plus by prime plus cy equals to f of x. Right, this is the second order differential equation. The highest derivative is a second derivative. Right, d squared y dx squared, or y prime prime. Okay, so when f of x equals to 0, it is what? An homogeneous differential equation. Right, it's an homogeneous differential equation. But when f of x is not equal to 0, like this case, right, this is a non-homogeneous differential equation. Right, so how do we solve non-homogeneous differential equation? In order to solve non-homogeneous differential equations, we need two functions. Okay, the first function is called a complementary function. So let's call it yc, right? It is a function of x, so let's call it yc of x, right? And the second function is called the particular solution or the particular integral. So let's call it yp of x. The solution of our non-homogeneous differential equation is going to be what? The sum of what? The complementary function and the particular solution, right? Yc of x plus yp of x. So how do we get the complementary function? To get the complementary function, what we do is to equate the function of x to 0. So when we equate f of x to 0, we are transforming our non-homogeneous differential equation into an homogeneous differential equation to obtain the complementary function. Okay, so here we're going to have y prime prime minus 5y prime plus 6y equals to 0. Okay, now this is an homogeneous differential equation which we can solve. Alright, I've made a video on homogeneous differential equations and you can check that out in the description below. So to solve this equation, the first thing to do is to get the auxiliary equation. Right, so the auxiliary equation is in the form am squared plus bm plus c equals to 0, which transforms our differential equation into a quadratic equation which we can easily solve. Okay, so a is the coefficient of y prime prime, b is the coefficient of y prime, and c is the coefficient of y. So we're going to have m squared, right? A is 1, b is minus 5, minus 5m, and c is 6, plus 6 equals to 0. When we solve this quadratic equation, we're going to have m to be equal to 2 or m equals to 3. So we can say that m1 equals to 2 and m2 equals to 3. Now, because we have two real and distinct roots, right? Two real and different roots, the solution is in the form a, constant a, exponential m1x plus b exponential m2x. Okay, so the solution becomes a exponential 2x plus b exponential 3x. So this is our complementary function, right? Our complementary function. Now we've gotten yc of x. The next thing to do is to get the particular solution. So let's put our complementary function in this corner here. Now, to get the particular solution yp of x, we take a look at what we have at the right hand side, right? The function of x that is at the right hand side. Now, we can have 6 types of functions at the right hand side. We can have a constant, right? We can have a value like maybe 50 or 25, right? That's a constant. We can have a linear function, right? Like 2x, 3x, right? And we can have a function of second degree, like this we have here, x squared. We can have a sine function like sine x, cos x. We can have an exponential function like exponential 2x, exponential 3x. Now, these different types of functions have different assumptions of y, right? We want to make an assumption for the particular solution. But I'm going to get to the other types in a bit. But let's take a look at when we have a second order function like this x squared, second degree function like x squared. Okay, so when we have a second degree function like x squared, we assume, right, that the particular solution is a quadratic equation. Okay, so we've already used a and b as our constants here. So let's use c, right, x squared plus another constant dx plus e. Okay, so this is our assumption for the particular solution. Okay, so what we do now is to differentiate. So if this is y prime becomes 2cx plus d, right? And y prime prime becomes 2c. So having gotten this, we're now going to substitute into our equation. Okay, so this is going to go in place of y prime. This is going to go in place of y prime, and this 2c is going to go in place of y prime prime. And so we have 2c minus, right, minus 5 into 2cx plus d plus 6 into cx squared plus dx plus e equals to x squared. And so we're going to have 2c minus, open the bracket, 10cx plus minus 5d plus 6cx squared plus 6dx plus 6e equals to x squared. So at this point, we want to arrange the left-hand side such that we can compare it to the right-hand side. So we're going to have 6cx squared minus 10cx, right, plus 6dx plus 2c minus 5d plus 6e equals to x squared. So we can also rewrite it as 6cx squared minus 10c minus 6d, right, x, right, plus 2c minus 5d plus 6e equals x squared. Now we can easily compare the left hand side to the right hand side. Okay, so we have what, x squared at the left hand side, we have x squared at the right hand side. So comparing, we have 6c to be equal to 1, which means that c equals 1 over 6. Okay, we have x at the left hand side, but let's say we have plus 0x, right? 0x is same as 0, right? So when we compare, we can say that 10c or minus into 10c minus 6d equals 0. Now we can substitute c into this equation, and we're going to have minus 10 into 1 over 6 minus 6, or let's say plus 60. Let's open the bracket now. Plus 60 equals to 0, and let's say 60 equals to 10 over 6. 2 can go in 10, 2 can go in 6, so we have 5 over 3, right? And if we cross multiply or divide both sides by 6, we have d to be equal to 5 over 18. Okay, so we've gotten c, we've gotten d. Now we can also compare the left hand side to the right hand side to have this to be equal to 0. Okay, so if 2c minus 5d plus 6e equals 0, we can substitute our c and d to get e, right? So when we substitute c, we have 2 into 1 over 6 minus 5 into 5 over 18 plus 6e equals to 0. Eventually, when we solve this, we obtain e to be equal to 19 over 108. So what do we have now? We have c to be 1 over 6, d to be 5 over 18, and e to be 19 over 108. Remember, we assumed that our particular solution is in the format cx squared plus dx plus e, right? Because we have a second degree equation as our f of x. Okay, so which means our particular solution is 1 over 6x squared plus 5 over 18x, right, plus 19 over 108. And so we can conclude that our general solution, right, which is what we have been looking for, which is the complementary function yc of x, right, plus the particular solution, right, yp of x, it is now equal to what we have here, right, a exponential 2x plus b exponential 3x, right, plus the particular solution 1 over 6x squared plus 5 over 18x plus 19 over 108. And this is the final answer to the question. Now, before you go, remember I said we have 6 assumptions, right, for 6 different types of functions. So here are the 6 different types of functions and the assumptions we have. So if we have a constant 5, 10, 20, 15, whenever we have a constant k, right, we assume that the particular solution is a constant c, right? Whenever we have a function kx, like 2x, 3x, 5x, right, we assume that the particular solution is cx plus d, right? And whenever we have a function like this, which we've done in this example, right, we made use of this assumption, right? So whenever you have, it could be 5x squared, 7x squared, right, we're simply going to assume that this is our particular solution. And whenever we have a sine x, a function of sine x or cos x, we're going to assume that this is our particular solution. And it could also be sine x or cos x. I mean, that should be the sixth one, which I did not include. And the particular solution will be c cos, right, x plus d sine x. All right. And whenever we have the exponential function, this is going to be our particular solution, which we're going to assume, and then follow the same process which we have followed in this video. I hope you learned something. If you did, please hit the like button, hit the subscribe button, share this video, leave a comment if you have any questions. Thank you very much for watching. See you in the next video.